I've got a job to do here. It's a CV joint of a car, drive shaft end. As you can see, the threads are badly damaged. The threads come off when the lad was stripping it. Not quite sure who'll be on it before him. We can't get a one, simple as that, not available, so I'm going to have to repair it. The thread on there is 22 by 1.5, common thread in the motor trade. There's two ways to do it. I can either weld this back up, remachine it, and put another 22 by 1.5 thread on it, or the simpler method is to use a 20 by 1.5 mil nut, which is slightly more than strong enough to pull the shaft into the hub, which means no welding, just machine that down to 20 mil and put the threads on. I have got a tap so I can get my thread dimensions from that. So I think that's what I'm going to do, machine it down, screw cut it, 20 by 1.5. A little bit of weight on the centre, doesn't need a great lot, just enough to hold it. Nip the chuck up for you now. Running nice and true. It's a little bit of a interrupted cut. There's a place there where you, what they call a stake nut, you hammer the nut into there and it locks it in. I'm going to put a nail lock onto it so it'll not bother me. Haven't got a great lot to play with here. Just about on 20 mil there. This bit's not good, but we'll surely get some threads on there alright. There's not a great lot else I can do with it really. A little bit for the tool to drop into, nice rounded corner as well. That's a 20 by 1.5 screw cutting tool, just make sure it's nice and square to the job, like that. Right, I'm just going to touch the tool off gently. It's interrupted cuts, not going to do it any favours. Right, we'll put a little bit of cut on and then engage the lead screw and measure it. Looks like 1.5, oh that's horrible that. These little tips don't like interrupted cuts at all. Right, that's absolutely spot on. That tap's fitting in there perfect. So we've got the pitch right. I could take a bigger cut, but I don't want to break the tip. See the thread indicator revolving. I'm going to put it on a hole number which is 60. I think on 1.5 you can lock it in anywhere. It's cutting lovely where it's got the full circumference to cut on. I'm doing my cut on the same setting just to make a spring cut. A bit of lubrication won't do any harm. Now it seems to speed up as it gets in towards the shoulder. It always does. This should be the last cut. Right, that's it, the job's a good one. Tighten onto the lock, onto the nail lock, and that's going to be fine. Happy with that. This bronze casting is of a traction engine of some description. There's a big whistle screws in there, and there's an ace of our screws into there. If you look underneath, it originally had a round flange. They're the 4 mounting holes, and the lad wants to make it a 2 flange one, 2 bolt one. So he's drilled the 2 holes, and my job is to make those 4 half holes disappear. This is bronze, it'll be quality casting. I've got some silicon bronze filler rods, so I'm going to use a TIG and weld them up or braze them up with silicon bronze. The first thing I'm going to do is cut the corners off so I can get the torch in and clean it up. It must be clean before you even attempt to weld it. Anything with TIG has got to be clean. I've opened the hole out so I can get into the bottom. That's the filler wire I'm going to use, silicon bronze. I'll be able to get the torch in like that. And I'll probably wash the bottom in and just work my way around and then do the corners as the last little bit. This stuff normally welds very well. The bronze, the silicon bronze will be a good match for that, good colour match and a good material match. This is the machine I'm going to use. It's an Artec TIG 261 AC/DC. I'm just welding on straight DC, high frequency start, the spots off, pulses off. I'm using a pedal and I've got it set maximum 260 amps. I'll not need maximum 260 amps. Once it starts to weld, I would think 130, 140 amps should get it going quite nicely. Let's wash it around and get a little bit into the job first. The high frequency start on this new machine is absolutely superb. It's instant. You put it to an electronic high frequency instead of the old fashioned method of using points. So the amplitude is varying as I'm welding. Working the pedal, especially on a bench like this, is ideal. You get really good control over the weld pool. That's the finished article all welded up. I made sure I put plenty of material on for it in the machine. There's nothing worse than having to re-weld something you've already done a weld build-up on. I mean, I really think he thought you could just slabber a bit of filler around the hole. You can't do that. You've got to cut things out and make sure you get plenty of penetration. Quite happy with the way that's turned out. I'd like to take this opportunity to thank all my subscribers for supporting us over the last year, in fact over the last several years. I haven't quite managed to get 100,000. I think I'm 200 short, so it's still possible. We've got a few days, you never know what might happen. So it's just basically, once again, time to say thanks for subscribing, thanks for watching, and I hope you all have a very, very merry, happy and prosperous new year.